Welcome to a new test and teardown video. This time it's a data precision 2540A1 digital multimeter with nixie tubes. Let's have a look. What? How many is that? 7? Oh, the first one is a little bit special, plus minus something like that. So we probably got 6.5 digit. It is very, very shiny. I cleaned it a little bit. So this is on kilo ohm AC and DC. And I think we've got 4 points. RX and VX. That's a little bit interesting. So that is when you are in ohms, you disconnect these and then you got a 4-point ohm meter. So there's a ratio something. Maybe this zeros the readout and then you can change the input from that point. I don't know. I like to experiment a little bit with that. So we also got a fancy expansion connector, and it is set for 230, and that is the good old Belden connector. And of course I got cables for that, so that should be fine. And then again the model and serial number and all that kind of stuff. Look at that, the transformer is mounted on some support to the back, probably both for mechanical and for heat. A little bit of corrosion. Some little modifications or upgrade that one. And there's a crystal and a capacitor mounted like that. Tons of relays. So down here we got the nixie tubes. And I think, yeah, okay, we got the switches. That will be some of the switches we see for the ranges right here. So they go to those point right there, and then you have the nixie drivers. We got some really nasty, slimy. Of course, I had to touch this with my fingers. So that is some slimy, sticky. Where is that coming from and why? There's probably a way to get this shield off. Look at all the different components to adjust. They are nicely indicated. And see, in here we got all the different tuning for this and that and adjustments, whatnot. Quite high end. I wouldn't have expected this. Inside the lid, I find this sticker here. It says something about calibration series 2000 DMM. And see the instruction manual. And then we got all the different ranges and all the different resistor adjustment points. Do this and do that. The ratio, kilo ohms and AC. That is quite nice. It's super shiny. It's impossible to take photos of this thing. I was so close to giving up. Taking away the bottom plate. It kind of glued itself. See here. All this corrosion and stuff here. So this part, the bottom lid to the side here, more or less glued itself due to some nasty slime. What the heck is that? And we also got, I don't know if you can see this. See? Some slimy droppity drop here. So I think I want to open and have a look in here. What is going on? Because the rest looks quite alright, but got all the shadow switches. That is some funny. Is that a modification with the two brown wires? There is another surprise in here. I am a little bit impressed. What have they done here? So we got some, it looks like a transparent circuit board, copper traces in some sort of a plastic substrate or something like that, and it adds, or it goes on top of all the relays. So what we see here, that will be the relay section, and then it interconnects to everything here on the circuit board. I think this is, you know, to avoid more than necessary cables going all over the place, but it's still full of cables and all that, right? But that is looking really, really nice. So that was some surprise, I must say. I still haven't found the source of this slime. Let's look at the other side. I probably expect some nice ICs and stuff. And this is really some sticky, slimy. And it goes on top of that. So they created some sort of isolation something. Ooh. So it's some sort of glue. I don't know what is the point here. Why didn't they cut, you know, a few more millimeters out of this to create a good isolation? I got a funny looking component. The one here with the yellow mark on the top. What exactly is that one doing? Maybe a voltage reference heated Zener diode or something like that. Yeah, so we got date codes 70, 72. 72, yeah. Those in the sockets, they could have been replaced. So there'll be some counters. Aha, counters, latches, and then nixie drivers. So that is more or less how it's. So I think it's from 1972 or something like that. Oh no. What is that? Look at the trimmers. What is going on here? So this is the silver plating went black and funny. And it's also down here. Look at that. At the end of this green component. Let me try and show you here. What is going on? This can't be good. This one looks a little brown. This one should probably look like these. And then we've got some capacitors and the power supply, but I still find no other sticky, nasty. No, this is just the way it was painted. Well. So I cleaned up all the silver whiskers with alcohol, and now the two trimmers and this test point looks more or less nice and clean. And also all the nasty slime here I cleaned up with alcohol as well. So now I feel I am ready for the first power on. Wish me luck. So let's try the first power on. Applying mains and nothing happens. It's using 45 watts. Look at all those digits. I really want to take a thermal camera and verify what is going on. I think it is quite a lot of power. But let's see if there's nothing. Oh, I really need to look for hot spots using the thermal camera. That will reveal if there is anything really bad going on here. And this is the thermal from last power on. So mains transformer and something here in the rectifier. Let me try and turn it on again. And then let's see what's going on. I'm really not happy about the transformer getting super warm. But there's also some stuff over here at the power supply I need to look a lot more at. Everything else here is quite normal. That will be all the ICs. But see? And that is not so good. The transformer getting warm this fast. By carefully inspecting the label here at the back, look at that. 12 watts. That is the normal power usage, but it's using 45. So this tells me something is definitely wrong, and I need to see if I can figure that out. So far, we got the transformer, and we got something in this area here where the power goes down. So there's some, I really can't see what is going on in here, but I will have to do a much deeper inspect. So let's look at that. I removed the rear plate and this switch, so now we can see some diode, and yeah, we got 5 diodes and a big black resistor. So here is what I will try and show you. So using my thermal camera, this is the spot. Now I'll try and turn on the unit for a few seconds. And then, ooh, look at that, shiny diodes. And then I turned it off again. So they go very warm. And then I take like this, and then I hold this in front of that one and that one. And then I know exactly which one it is. You know, it's normally difficult to navigate around with a thermal camera and then see what exactly is it. So this is a good trick. After a little bit of playing around with the thermal camera and the power supply, I was able to figure out it was indeed the capacitors. So the old capacitors from 1972, they were like half shorted. So they were using that many watts, and how is that possible without warming up the capacitors? So that is some weird stuff. But with 2 new capacitors, yeah, this unit uses only 17 watt. So that's quite good. I was able to find a web page, a Dutch web page. I will put the link in the description. And this guy got exactly the same unit, also from 1972. And he found all the schematics and manuals and everything. He even said the unit costed in 1972's money $11.95. So I went to the inflation calculator and I figured out this is $8,917 today's money. Oh my goodness, so that is a lot for a really sexy nixie voltmeter. Oh yeah, about the schematic. You gotta see this this schematic. It's very funny the way that the power supply here is made. And we got those 2 transistors, and they're coupled with an op amp, and they're measuring the output voltage and doing a oven-heated Zener reference. And look to the right. Can you see the line that shorts the output to ground? What the heck is going on here? So there's also a big mistake in that schematic, so that's quite funny. So let's try and play a little bit with this instrument. I am now in 100 volt range, and this should be about 15. Only if I turn it on. Yeah, it's okay. It is reading a tiny little bit too low. Let's give this time to warm up. Remember, we got oven heated Zener references and all that kind of stuff. So I just leave it turned on for a little while, and then I will continue this clip. So I think it's 25 minutes later. And I can also see the current consumption, or the power consumption on mains is now stable at 13 watts. So the oven heated voltage references and all that kind of stuff is now stable. And this also had an effect on the readout. So here's my 15 volts. And now it is only very little, 5 millivolts in the 100 volt range. And if I swap positive and negative, it's exactly the same number. And of course we get the negative sign. So all that seems to be working quite well. Let's see how it works with this if I go in and change the input to 9 volts. So now I go to the 10 volt range. So if this is 10 volt, this is confusing, isn't it? Why can't it? Oh, so this is how it works. So 10. So 12 is plus minus 12, not 10. Why don't you guys write exactly the number here? Well, it could have been 12. But that is of course not possible. But it's nice to have a little bit of headroom, so you know you want to read or measure about 10, and then okay, you can handle a little bit more. And yes, this is definitely 12.00. And again, the unit works really good. Super nice. I want to show a few slides from the manual, and they say about, if we go to section 4, principles of operation, they talk about the block diagram first, and they call the AD converter section for a triphasic trademark analog to digital converter block. How about that? So in 1972 they could come up with all sorts of sexy stuff like that. But if we look a little bit down and zoom in on the analog converter, I mean, we have all seen this a million times before. It is just a normal slope converter, and they also call them dual slope or capacitor charge timing converters or something like that. It isn't really anything super duper crazy or special, to be honest. I will show a few slides of their block diagrams here, and that is, I mean, if you want to see some more details on this unit, please use the link I put in the description, and then you can download the entire PDF files and see all the nice details there. So I think this is the end of the video. I will of course put the metal shields back on here and assemble everything and make it nice and shiny again. So thank you very much for watching. I hope to see you soon again. Bye bye.